Hi everyone, today we're chatting about containers and how they work and what's involved. So let's get into what are containers in AWS and just in general, actually. How do containers work? So we know that EC2 instances are like accessing more computing juice, computing power through virtual computers. So we say we need some more computing power. We're going to create like another computer that I have in front of me, but it's all going to be virtual through the internet so that I don't have to actually go out and get the hardware. Now, when we set up this new virtual computer, which we do through EC2 instances, then we have to set a lot of different things like storage, the amount of computing that we need. We need to decide what it's going to specialize in, what family it's going to be part of. And then we also need to give it an operating system. Operating systems are like the manager for your computer. So I run a Mac operating system, but there's also Windows operating systems and Linux and all sorts of other different operating systems. Now, when we're talking about containers, they're kind of similar to EC2 instances, but they don't have a operating system. So whereas an EC2 instance is like your entire computer that you're setting up, a container actually shares the operating system of its host. Now, what is the host? The host is like the main machine that is controlling everything else. So when you're creating a whole bunch of different containers, you're creating like these other little environments around the place, and they're all connected to the main person in charge, the main computer in charge, which is your host. And your host, when you're using containers, actually sets the operating system, and all of your containers go, all right, that's exactly what we'll use. We're just going to go with that. We don't really care about the operating system ourselves. We're just going to focus on everything else. You bring the operating system. We're going to have a good time. So why would we even need containers? Now, the advantage of using containers is that you can put all of your code dependencies, your entire application, any additional configuration that you might need to set up to run your application properly. There's a lot of setup that might go involved in actually running a website or an application. There's all sorts of other settings that need to be done, things that need to be prepared beforehand. And if you want to send this to lots of different places around the world and make sure that it can run everywhere, then it's going to be a lot of setup for every single time that someone wants to use your application. They're going to have to make sure they've got all of the right configuration, they've got all of the right code, they've done it exactly how you want it to be done. But you can't trust everyone to do this on their own. They're going to mess it up. So what you're saying is, we're going to actually package this all up in a lovely little container for you. Everything is there ready to go. And here is your little container. You can open it and just start to use that. And it's going to be all set up exactly as what we want. Now, why this is fantastic is because you've got this little, container here with all of the good things that you need. And then you can send it out to different hosts who have their own operating system. And you know that it's always going to run the same no matter what operating system it's on. This is a big difference to virtual machines or EC2 instances, because for every individual EC2 instance, you have to specify and set up the operating system. So if I wanted to send out 100 of them, then I've got to set up the operating system for every single one. But if I use a container, then I can just send it out and I know that it's going to run flawlessly, hopefully, on every single device, no matter what operating system they have. Another great way to think about it is, imagine that you've got a group of friends and you're all going out to a cooking class, all right? Everyone brings along their own ingredients. Everyone might bring along their own inventions or their own creativity, their own recipes, but you all go into this commercial kitchen and you're making use of the tools there, the ovens, the stoves, all of the pots and pans that they have. You don't have to worry about every single individual person having their own kitchen, but everyone is there cooking their thing, doing whatever they want to do. It's the same sort of thing where the kitchen is the operating system and all of the different people coming along with their different recipes is like your containers. So each container is saying, here's my ingredients, here's my recipe, and you're just sharing the same operating system. And you know that because you've told everyone the ingredients they need, the recipe that they're going to cook, the instructions on how to cook it, that they can just go along to whatever kitchen they want and they can create that exact meal. But you don't have to worry about the kitchen, All right, you don't have to worry about setting up hundreds of kitchens. You just worry about what's in that container, about the recipe and the people and the ingredients. Make sure that that's all ready, and then you can just send it off and you know it's going to be great. So, what actually goes into containers? Well, you've got application code, dependencies, and configuration. What doesn't go into your container is the operating system, which is what we just talked about. So, when we think about virtual machines versus containers, there's a couple of different things to keep in mind. Virtual machines are very heavyweight because you have to set up every single detail. They have to run their own operating system. So you have to make sure that you've thought of that and covered that. And they're much slower because of all of this. Compared to containers, which are very lightweight, they share the host's operating system and they're much faster. A great example of containers is actually Docker. So Docker is a company that builds this sort of software so that you can actually put all of your applications and things into containers and off they go. And they're called Docker because it's like shipping containers, where when you have a shipping container, it's got everything that you need inside it, but you can move it from different environments, from one country onto the boat, off the boat, into another country. That's why it's called Docker. Now, once we have our containers that are all ready to go, and we actually send them out to all these different machines or all these different places so that they can go in and run successfully, then we actually need something that's going to manage all of these different containers that have been sent out into the world. How do we track them all? Where have they gone? How do we know if they're working or not? This group of containers that we set out is called a cluster. So cluster is the descriptive word for basically a whole bunch of different containers that are going out and doing their thing in different machines. And then managing those is called orchestration. Orchestration tools are very, very useful and they help with a whole bunch of different things, from managing the actual running of the containers to what to do if things start to fail or there's errors or things just start to fall apart, to monitoring all of the different deployments of containers across hundreds of different machines. In AWS, of course, there's a whole bunch of different services that we can use to actually manage containers, clusters, and the orchestration of them. First up, we have the Elastic Container Service. This is one of the most simple ways to run containered applications in AWS. It's a fully managed system that does the deploying, the managing, and the scaling for you. ECS is great with Docker, so it's going to help you to run all of your different Docker containers across EC2 instances. It allows you to define exactly how you want your different containers to be run across these instances, how you want them to scale up and scale down, and it even helps with the auto scaling and load balancing. Next up, we have the Elastic Kubernetes service. Kubernetes is another tool for containers like Docker, and it does pretty much exactly the same thing as before, but it specializes in Kubernetes. Finally, we have the Elastic Container Registry. This is where you can view all of the different instructions that you have for how your containers should be set up, any files or dependencies or any things that they're going to require within their little container to run properly, and the security that it needs to actually make sure that your whole container is actually secure and it's not going to be hacked or anything like that. It's mainly for helping you to store and manage all of the different files and docs and setup that goes into containers, so that then you can deploy them using the Elastic Container Service or the Elastic Kubernetes Service. Together, they're going to actually work to help make this whole process seamless, but they have specific individual roles in the whole picture. Phew, what a mission. Containers are a big topic and they can take a bit to get your head around. So maybe pause, have a cup of coffee, have a cup of tea, write down some notes, and then get in and start playing around with it. We'll see you in the next video.